Next is available energy or availability of a steady flow process or open system. Okay, so let's suppose we are having any open system. Okay, initial condition is, let's suppose pressure is P1, volume is V1, temperature T1 and so on, internal energy U1. Final condition, pressure P0, volume V0, temperature T0, internal energy U0, enthalpy H0 and so on. Getting this? Okay, this is our open system. And in this process, this is, let's suppose, releasing a heat a heat Q, and this is producing a work which is nothing but W shaft. This is as good as the turbine. We have studied about the turbine in first unit, in first law. Okay, so here the intake pressure is P1, V1, T1 and so on, outlet pressure P2, V2 or P0, V0, T0 and so on, and in this process this turbine is producing certain work which is nothing but shaft work. Okay, and let's suppose it is also releasing some heat, let's suppose Q amount of heat it is releasing. So first we want to determine the available energy. Okay, available energy means maximum work. As I told you, maximum work उसमें से हम कितना निकाल सकते हैं. So इसमें से maximum work कितना निकाल सकते हैं. So first work is nothing but this shaft work. Okay, now apart from this Q heat is rejected. Now this Q heat has also certain potential work, और उसको कैसे हम convert कर सकते हैं. So we can again put one heat engine between this and surrounding, which is at temperature T0, and this will deliver work W engine. Getting this or not? Okay, so total work, maximum work which can be extracted from this open system, this maximum work is nothing but W shaft plus W engine. That's it, same thing. Clear or not? Maximum work is nothing but W shaft of this open system plus W engine. Clear or not? Okay, now how can we determine this W shaft? So for this we will apply the first law for a steady flow process. So what is first law for a steady flow process? H1 plus V1 square by 2 plus Z1G plus Q is equal to S2 plus V2 square by 2 plus Z2G plus W, steady flow energy equation. Now here work done is nothing but the shaft work, which is positive work because work is done by the system. First thing, heat is rejected by the system, so this heat will be taken as negative. Clear or not? Okay, now from here we can determine this shaft work. So this shaft work will be equal to what? H1 minus S2, okay, plus V1 square by 2 minus V2 square by 2 plus Z1G minus Z2G. Getting this? Okay, now apart from this there will be minus Q. Okay, and final final condition is 0 not 2, so this will be V0 Z0, this will be V0 H0 and Z0. Clear or not? Okay, so this is nothing but the shaft work, total shaft work. Now what about engine work? So engine work, as we know how to calculate the engine work, so efficiency is equal to 1 minus T0 by T1, and which is also equal to W engine divided by Q, or you can say this W engine is equal to Q minus Q by T1 into T0. Getting this or not? Okay, so what you have to do now is you just have to add these two. Okay, and let us see what will be the final result. So this I will do it here. So this W max will be equal to, so this will be equal to H1 minus H0 plus V1 square by 2 minus V0 square by 2 plus Z1G minus Z0G minus Q, okay, plus Q minus this Q by T1 is nothing but del S, change in entropy, S1 minus S0. Okay, so this will be equal to T0 into del S, T0 into, or you can say S1 minus S0. Okay, because S1 is more than that of S0, heat is getting released from here. Clear or not? Okay, so this W max, this can be further written as H1 minus T0 S1 plus V1 square by 2 plus Z1G, okay, minus H0 minus T0 S0, okay, plus V0 square by 2 plus Z0 into G. Getting this? This is maximum work, or you can also call it as available energy, maximum work. Now what about maximum useful work? Now because in previous case it was a closed system and it was expanding against the atmosphere, okay, there was a volume change. But in this open system, as we study about the control volume, there is no such volume change. It does not has to expand against the atmosphere. So maximum useful work obviously will be equal to maximum work. So in case of this open system, in case of a steady flow process, available energy and availability both are same, because maximum work will be equal to maximum useful work, because there is no expansion against any surrounding. Getting this or not? Okay, so you can say this W useful max is also equal to W max, as there is no expansion against surrounding. Clear or not? Okay. Now this term H minus T0S, H minus T0S, this is nothing but taken as B, which is nothing but Keenan function. इसको हमने अलग से function का नाम दे दिया, that is nothing but Keenan function. Okay, so you can get it as W useful max or W max. This will be equal to, this will be B plus V1 square by 2 plus Z1G minus B, this will be B1 B naught plus V naught square by 2 plus Z naught into G. Okay, now here this whole function B plus V square by 2 plus Z into G, this is nothing but open system availability function, what we call as psi. Okay, so this will be B plus V square by 2 plus ZG, this is nothing but psi, which is nothing but open system availability function. Open system availability function. Okay, so further this can be written as this W useful max or W max, this will be equal to psi 1 minus psi 2, change in availability function or change in open system availability function. Getting this or not? Now if we are neglecting, let's suppose, the kinetic energy and potential energy from this particular function, if kinetic energy and potential energy are neglected, okay, now what will happen? So this will be, this term will be neglected, this term will be neglected, and you will just get total available energy or W max or W useful max. This will be just change in Keenan function. Okay, so total available energy is actually change in steady flow availability function, and if kinetic energy and potential energy are neglected, then total available energy or availability is nothing but change in Keenan function. Clear or not? Okay. Next is the Helmholtz or and Gibbs function. Now we know for non-flow process, maximum work we have derived as U1 minus T naught S1 minus U2 minus T naught S2. Okay, if the system is changing its state from state 1 to state 2, the maximum work which can be obtained is U1 minus T naught S1 minus U2 minus T naught S2. Okay. Now if temperature is constant for constant temperature process, this T naught will be equal to T1, which is also equal to T2. Getting this? Okay, so this W max will be equal to U1 minus T1 S1. I can replace this T naught either by T1 or T2 minus U2 minus T2 S2. Okay, so this U minus T into S, okay, this is another function which is nothing but Helmholtz function, and this is denoted by A. This is nothing but Helmholtz function. Okay, so the maximum work in a closed system, if it is changing its state from state 1 to state 2, the maximum work which can be obtained is nothing but change in Helmholtz function. Okay, and as it is clear from here that this formula can be used only for the closed system, for non-flow process only, and not for the flow process. This is the restriction for using this formula. This Helmholtz function can be used for non-flow process only and not for the flow process, not for the open system. Getting this or not? Okay, first thing. Now what about open system? So for open system, for flow process or open system, as we have already seen, what is W max? So this W max for open system is nothing but U1 or sorry H1 minus T0 S1, okay, minus S2 minus T0 S2. Okay, if it is changing its state from 1 to 2, H1 minus T0 S1 minus S2 minus T0 S2. Now this further, this H can be written as H, as we know enthalpy is equal to U plus P into V. So this W max here can be written as U1 plus P1 V1 minus T0 S1 minus U2 plus P2 V2 minus T0 S2. Okay. Now, for constant temperature process, if temperature is constant, that means T naught is equal to T1 is equal to T2. So, this W max can be written as U1 plus P1 V1 minus T1 S1 minus U2 plus P2 V2 minus T2 S2. Getting this or not? Okay. So, here another function you have got, this U plus P into V minus T into S is nothing but G, which is nothing but Gibbs function. Okay. So, this maximum work in open system, in case of open system, is nothing but change in Gibbs function. Okay. So, maximum work in case of closed system is nothing but change in Helmholtz function, and maximum work in case of flow process or open system is nothing but change in Gibbs function. Clear? And you can write down one note here, at equilibrium the value of this Helmholtz and Gibbs functions are minimum. Next is irreversibility. Now, what actually is this irreversibility? I have already told you, total loss in available energy because of some irreversible processes is nothing but the irreversibility. Okay. Now for the closed system, as we have seen, in order to determine the maximum work, what we assumed, we first wanted to determine the maximum available energy, how much potential work is available there. So, what we did here was we calculated this W max, which was equal to W expansion plus W engine. Getting this or not? Okay. But is it feasible to have such engine? Suppose the engine, this closed system is releasing certain amount of heat, let us suppose Q1. So, can we produce some work from by using that Q1? No, obviously practically not feasible. Getting this or not? So, this much amount of work cannot be recovered. Getting this or not? Okay. So, this is nothing but irreversibility here. So, this irreversibility, what will be irreversibility here? The maximum work which can be obtained minus actual work. Actual work is nothing but the expansion work. Maximum work which can be obtained minus this actual work, expansion work. Okay, because this is the work which cannot be obtained. Okay, which is not feasible. It is not feasible to have such engine in if any closed system is releasing some heat, you cannot put heat engine at each and every place. Getting this or not? Okay, so this is ultimately wasted. Now, what will be this expansion work? What will be the value of this expansion work? So, for that, what we did was we applied the first law, Q is equal to del U plus W, okay, or you can say this will be minus Q1 or minus Q is equal to del U, which is nothing but U2 minus U1. Let us suppose this is changing its state from 1 to 2. So, this will be U2 minus U1 plus W expansion, which we want to determine. So, this W expansion from here will be equal to U1 minus U2 minus Q. Getting this or not? Okay, so just put the value. So, this total irreversibility, this will be equal to W max, as we have seen, is U1 minus T naught S1, okay, minus U2 minus T naught S2. This was W max minus W expansion. So, this W expansion will be equal to U1 minus U2, okay, minus plus Q. Clear or not? Okay. Now, this U1 minus U2, this U1 minus U2 and this U1 minus U2 will be cancelled out, and finally we will get what? So, this will be equal to, this will be T naught into S2 minus S1 plus Q. Getting this or not? Okay. Now, what is this S2 minus S1? This S2 minus S1 is nothing but change in entropy of the system. Initial entropy was S1, final entropy after expansion is, let us suppose, S2. So, this S2 minus S1 is nothing but change in entropy of the system. So, this will be T naught into del S system, first thing. Getting this? Now, what is this Q? Okay. Now, what is this Q? So, this Q is nothing but the energy, the heat released to the atmosphere. Okay. Here we are not running this engine. Okay. Simply the heat Q is released to the atmosphere. Now, what will be the change in entropy of the surrounding? Now, because this Q amount of heat is getting released to the atmosphere, so change in entropy of the surrounding is nothing but Q by T naught. The temperature of surrounding is T naught. So, change in entropy of the surrounding will be nothing but Q by T naught, or you can say this Q is nothing but T naught into del S surrounding. Getting this or not? Okay. So, just put the value. So, this will be Q T naught into del S system plus T naught into del S surrounding, or you can say this will be equal to T naught into del S universe. So, this is total irreversibility, which is nothing but T naught into del S universe, change in entropy of universe. Okay, and change in entropy of universe, as we know, is also called as entropy of generation. We have discussed about the entropy in the previous unit. So this change in entropy of universe is nothing but entropy generation. So T naught into S generation. This is nothing but the irreversibility of a particular process. So if we want to calculate the irreversibility, just calculate change in entropy of the universe. We know how to calculate change in entropy of the universe into T naught, the surrounding temperature. We will get what? Irreversibility for a certain process. Same thing is applicable for open system also. This I am leaving it up to you. Same thing you have to do as for open system. Obviously, this W max will be equal to W shaft plus W engine. For open system, just remember that W max will be equal to W shaft plus W engine. Okay. Now again this engine has to be subtracted, so this irreversibility for open system will be equal to W max minus W shaft. That is nothing but irreversibility. So just put the value and you will get it. I will tell you how. Maximum work, as we know, is H minus T into S, H1 minus T1 S1 minus T naught S1, S2 minus T naught S2, okay, minus shaft work. How can we determine this shaft work? So applying this equation, H1 plus V1 square by 2 plus Z1G, neglecting potential and kinetic energy, we will get what? H1 plus Q is equal to S2 plus W, and you will get what? W shaft is equal to H1 minus S2, and this is because heat is rejected, this will be minus of Q. Getting this or not? Okay, so this will be minus W shaft, so this will be H1 minus S2 minus minus plus of Q. Getting this or not? Okay, now just put the values. Just solve this. H1 minus S2 will be cancelled out, and you will get what? This will be T naught into S2 minus S1 plus Q. Again you are getting what? T naught into del S system, and Q is nothing but T naught into del S surrounding, and you will get what? T naught into del S universe. Okay, so this irreversibility is nothing but T naught into del S universe, both for open system as well as for closed system. And this theorem is nothing but Gauss-Stodola theorem. Irreversibility is equal to T naught into del S universe. This is nothing but Gauss-Stodola theorem. Clear or not? Next is the second law of efficiency. Now we have seen what actually was the first law of efficiency. First law of efficiency हमने define किया था work done by Q1. That means total कितनी heat हम provide कर रहे हैं, and out of which how much amount of work is getting delivered. This was first law efficiency, which, and as we know, first law is concerned with the quantity. Okay. Second law is concerned with the quality. How much quality of work is are we extracting? Getting this not? First law was concerned कि आपने कितनी heat उसमें provide की है और उससे कितना work आपको मिल रहा है. सेकेंड लॉ को हम कैसे डिफाइन कर सकते हैं? सेकेंड लॉ एफिशिएंसी को हम कैसे डिफाइन कर सकते हैं? सॉरी, सेकेंड लॉ एफिशिएंसी कैन बी डिफाइंड एज एक्चुअल वर्क आउटपुट डिवाइडेड बाय मैक्सिमम पॉसिबल वर्क आउटपुट, एंड दिस एज वी नो इज बिकॉज ऑफ इरिवर्सिबिलिटी. ये जो डिफरेंस जो दिख रहा है बिटवीन दिस डब्ल्यू मैक्स एंड डब्ल्यू, दैट इज नथिंग बट इरिवर्सिबिलिटी. अभी हमने इसको डिफाइन किया डब्ल्यू मैक्स माइनस डब्ल्यू. ओके, सो दिस इज नथिंग बट दिस इज बिकॉज ऑफ द क्वालिटी ऑफ एनर्जी इज डिग्रेडिंग. Okay, so उसके कारण जो efficiency है that is nothing but second law efficiency. Getting this or not? Okay, now further this can also be written as work done upon maximum work done. This can be written as minimum exergy required or minimum available energy required to perform a given task divided by actual available energy required to perform the same task. This W by W max can also be written as minimum exergy divided by actual exergy. Getting this or not? Okay, now further इसको हम क्या लिख सकते हैं? This first law, as I told you, is W by Q1. Getting this? Okay, now if I divide it by W max, I will get what? W by W max into W max by Q1. Okay, now what is this W max? W by W max is nothing but this second law efficiency. Okay, and this W max by Q1, what is this W max by Q1? This is nothing but Carnot efficiency, maximum work delivered divided by Q1. This is nothing but Carnot efficiency. Okay, so this first law efficiency can be written as, this is W by W max, which is nothing but second law efficiency, into W max by Q1 is nothing but Carnot efficiency. Getting this? Or you can say this second law efficiency will be equal to first law efficiency divided by Carnot efficiency. So this is how we can define this second law efficiency, which is concerned with the quality of the work. Okay, maximum कितना हो सकता था work बट एक्चुअल में हमको कितना मिला बिकॉज ऑफ सर्टेन इरिवर्सिबिलिटीज. Getting this now? Okay, so this is nothing but the second law efficiency.